Hey there, Algebra 2A. Today we're going to take a look at Lesson 4, Identifying Functions and Using Function Notation. Our objective learning target is identify functions by inspecting the domain and range. We'll use mapping for that, and by using the vertical line test, and then use function notation to evaluate functions. Below here is a warm-up you can do on your own to prepare you for Lesson 4. Some new concepts that we'll take a look at in Lesson 4 and keep reviewing these as we talk about functions throughout the year. A relation is a pairing of two variables. We'll call those two variables inputs and outputs. So these two variables are usually in a situation that relates to each other. So for example, you buy a certain amount of pounds of grapes, and then you have an output, which would be the cost of all those pounds of grapes that you buy. Your domain would consist of the input value. So in that situation, that would be the amount of pounds of grapes that you buy. The range of the function is your output values, and that would be the cost. So you input how many pounds you buy, and then you output the cost of the grapes. The input value is designated with the letter X, and that is also called the independent variable. The dependent variable is indicated with the Y, which represents your output. So we can call the independent variable an input or an X value. The dependent variable is an output and also considered a Y value. A function is a special relation where each member of the domain, the X's, is paired with one and only one member of the range. Our goal today is to use two strategies to determine if a relation is a function, and we're going to use that definition of function where each member of the domain can be paired with only one member of the range. The strategy we're going to use is called mapping. So we're going to determine if these depict a function, and then once we do that, we'll identify the domain and the range. So using a mapping diagram, we're checking to see each domain value, which your domain values are going to be your X values on the left side of your mapping and your Y's are on the right. Each X value can only have one partner. So I like to think of it kind of like as a relationship. So if you're in a relationship with somebody, you should only have one partner. So the 2 is only partnered with the 4, is pointing to it. -5, if we look, -5 is partners with the 7. -5 is also partners with the 8. So anytime where a member of the domain is paired with more than one member of the range, this is not a function. So I'm following here, the 2 goes with the 4. The 5 is partnered with 2 separate people. So that would mean that this one is not a function. The second thing we're going to do is identify the domain and range. The domain represents the X values, which we talked about from above. So your domain, you're going to make a colon and then a bracket is your X values, and then you're going to make a bar to separate. And then you've got a 2 and a -5 that represent your domain. Then we'll close that off. Your range is your Y values. We'll make a bar, and then we list the the range values 4, 7, and 8. In the second problem, we'll set up a mapping diagram and then draw out our arrows to see where the pairings are. So we'll start constructing our mapping diagram, and then we'll start to pair each ordered pair, each domain value with its range value. The 4 is paired with the 5. The 4 is also paired with the 7. 3 is paired with the 9. -3 is paired with the 9. 0 is paired with the 12. If we look right here, since the 4 maps with the 5 and the 7, 4 is paired with the 5, 4 is paired with the 7, this also is no function. Then the last thing we do is we can write in our domain values for the X's, our range values for the Y's to complete our problem. So in each case, we had one member of the domain map with 2 members of the range, which means there's no function. Lastly, up here, if you look at this mapping, the 2 is paired with the 6, the 3 is paired with the 6. Now, this looks very similar to how these last problems looked, except now my domain only is paired with one range here, domain is paired with one range here. So it is okay if each domain is paired with the same range, but not vice versa. And then 4 is paired with the negative 12. So this one is, yes, a function because each domain only has one mapping coming off of it, or one arrow coming off of it, pairing with the range. So that would be an example of a mapping diagram that represents a function. The second way we can identify function is by using the vertical line test. A vertical line passes through more than one point on a graph, then it is not a function. So we'll take any type of vertical line and we are going to slide through to check to see if it passes the vertical line test. So imagine I slid this green line over and sliding it through, you can see it hits right here, it hits right here. So since it hits 2 times, that one is no function. And again, I'll slide my green across, and every time I slide a vertical line, it only hits 1 point. So this one is yes, represents a function. Next thing we'll take a look at is function notation. So function notation takes the y and replaces it with what's called f of x. F is used because that's what function starts with, and then the f of x means that the function depends on x. Your y variable is that dependent variable, depends on what x is. So this f of x is designating that the function depends on whatever x is. So in the past, we might have seen this relation. So 3x plus 2, y equals 3x plus 2. Maybe it's the cost of bowling. So it's $3 per game plus $2 to rent shoes. And then y represents the total that you have to pay. So x, however many games you play, is going to determine how much total you have to pay. So if you play 3 games, 3 times 3 plus 2, 11, that means your cost is going to be $11. If we play 3 games of bowling in this f of x function, so f of x, we're going to say the function depends on those 3 games. So f of 3 is going to equal 3. And now instead of this x here, we're going to replace that with the amount of games played, 3 times 3 plus 2. So f of 3 is going to equal 11. So function notation shows what you're inputting into the function, and then the result 11 represents the output of that function. In example 3, we're given 2 functions. H of x, we can use different letters, so h depends on x, is equal to negative 5x squared plus 2, and p of x is equal to x over 2 minus 3x. We are going to find h of negative 2. So this is similar to above. When we played 3 games of bowling, we found f of 3. We're going to take that 3, we're going to put it into the x variable of the function. In example 3, we have 2 different functions to choose from, an h function and a p function. Since this says h of 2, we are going to use this h function over here. So to find h of negative 2, we are going to take the function negative 5x squared plus 2, and we're going to replace the x with negative 2. From there, you have the option of solving using order of operations. So negative 2 squared is 4 times negative 5 is negative 20 plus 2 is negative 18. Or we can take and put that into our calculator. Your calculator will do the order of operations for you. So here it is. We got negative 5 times negative 2 squared plus 2. We should get negative 18. And there it is. So you can always input the expression into your calculator. Your calculator will solve the order of operations as well. For example 4, we are going to look at the situation and find the cost of a 2, 3, or 4-minute call. Express your answer as an ordered pair in set notation. We'll talk about what that is. Identify the domain and range, which we have set up already, and then determine if the set of ordered pairs represents a function. First, let's find the domain and range, and then we can start to find the ordered pairs and determine if it's a function. So the domain, we have a 2, 3, or a 4-minute call, and I'm designating the time as the x value because that is going to determine the cost. So the cost depends on the time on the call. Now we'll find the cost of a 2, 3, and 4-minute call. So the company charges 25 cents per minute for 3 minutes and then 10 cents for every minute thereafter. So the longer you're on, then it gets a little cheaper. So 2 minutes will be charged that 25 cents for each minute. So that's going to be a 50-cent call. A 3 minute still is going to cost the 25 cents per minute. So that's a 75-cent call. And a 4 minute, since the first 3 minutes cost 75 cents, then 10 cents after that, that's going to be an 85-cent call. Now that we have our domain and range, we can write our answers as ordered pairs. So to do that, we can set up a bracket, pair the 2-minute call with 50 cents, 3-minute call with 75 cents, 4-minute call will be 85 cents. And then determine if it's a function. So we'll set up our mapping diagram. The 2 is paired with the 50 cents, the 3 is paired with the 75 cents, and the 4 is paired with the 85 cents. So each x value maps with only one y value. So the mapping is consistent, only one in each. So this one is yes, a function. Part B, our company is going to charge 25 cents per minute for plan A and then 50 cents per minute for plan B. In the essence of time, we're just going to take a look at 25 cents per minute for plan A. So we can start by finding our domain and range. So our inputs are 2, 3, and 4. And then for 2-minute call, we'd have a 50-cent cost. 3-minute call would be 75-cent cost. And a 4-minute call would cost us $1. We can then write our ordered pairs in set notation over here. And lastly, we'll use our mapping to check. So 2 is paired with 50 cents, 3 is paired with 75 cents, 4 is paired with $1. So since each x value maps with one y value, this is also yes, a function. So that wraps up our Saxon lesson 4, where we learned 2 different methods to identify if we have a function, and we also introduced function notation and how to evaluate functions. You're now ready for your lesson 4 assignment on Delta Math. Good luck, and we'll see you next time.